morning students. In this class we are going to start with the atomic spectra. Students, if you have to understand Bohr's atomic model, we should know what you mean by emission spectra, because there we are going to study the line spectrum of hydrogen atom. So we should have a thorough knowledge of this atomic spectra. So let's go through it. I had written some material for you so that you will not find difficulty. This is completely a theoretical topic. Let's begin with it. What is atomic spectra? The splitting of a beam of light into radiations of different wavelength or frequency. Different wavelength और frequency की जो radiations होती है वो split हो जाती है white light on passing through the spectroscope. That means spectroscope हम ले रहे हैं. Spectroscope के अंदर you can take the prism or the diffraction grating. So if a beam of light when it passes through the prism or diffraction grating, it splits into its various components. It splits up into different wavelengths or frequencies, and this phenomena is called as dispersion. You all must have studied dispersion in physics. Okay, now the pattern which is obtained, pattern is the photograph which is obtained on the screen, that is the photographic plate. It is called as atomic spectra of given substance. So in nutshell, what do you mean by atomic spectrum? Whenever a beam of light passes through a prism, then the splitting of it takes place into the radiations of different wavelengths and frequencies, and the pattern which is obtained, it is called as atomic spectrum of that particular substance. Okay, now atomic spectrum, it is of two types. The first one is emission spectrum and the second one is the absorption spectrum. Okay, so first we are going to start with the emission spectrum. Now emission spectrum, what do you mean by it? Let's go through the meaning. When the radiations emitted from the source which is emitting its own light, like if you are taking, suppose not own light, sun, it is giving the white light, bulb, it is giving the light, or bypassing. See, we had taken two types of sources. The first one, it is the sun. Second one, it is the bulb. Both are giving the light of their own. Okay, bulb is also giving the light, or any hot glowing body. Okay, so first one is the sun, bulb, or any hot glowing body, and the second type of source is by passing electric discharge through a gas at low pressure. Means कोई सी भी गैस है low pressure पे आपने maintain कर रखा है, and when you pass the electric discharge through it, then it gets excited. Atoms get excited, in that electrons get excited, or by heating the sample at high temperature. और आप ये excitation किसके through कर सकते हो? On the Bunsen burner, if you heat the substance, the vapors of the substance, then also the electrons get excited to high energy levels. And when such radiations are passed through prism and then they are analyzed, then the pattern obtained on the screen is called as emission spectrum. ठीक है? Emission spectrum क्या है? किसी भी source से if the radiations are allowed to pass through prism and the splitting takes place and जो pattern हमें मिल रहा है, that pattern, it is called as emission spectrum. Okay, now source can be either, it can be sun, it can be bulb, or any hot glowing body, or it are the vapors of the gas maintained at low pressure, or it can be the heating of sample by the Bunsen burner. So we are passing the radiations through the prism and splitting is taking place, और वो जो pattern हमें मिल रहा है उसको हम क्या बोल रहे हैं? Emission spectrum. Now emission spectrum, it is of two types: continuous emission spectrum and the discontinuous or line spectrum. Okay, discontinuous emission spectrum or the line spectrum. Okay, now we are dividing emission spectrum into two types: continuous and discontinuous. First, on the basis of the source, from which source the radiations are coming. Fine. So in the first case, continuous emission spectrum, when a white light from any source is analyzed by passing through the prism, whenever a white light that is from the sun, अगर हम sun की बात कर रहे हैं, white light from the sun is allowed to pass through the prism and then it is analyzed, it will give a continuous emission spectrum. और उस स्पेक्ट्रम की जो पैटर्न हमें मिलेगा उसका स्पेसिफिक पॉइंट क्या होगा स्टूडेंट्स? देयर विल बी splitting off, it splits off into 7 different colors. वो जो white light है, it splits into 7 different colors from violet to red. Okay, you can see the diagram over here. White light is allowed to pass here and a slit has been taken. From this slit, a ray is allowed to enter here, and when it passes through this prism, dispersion takes place. That means it splits into the 7 colors, violet to red. Okay, and each color merges with the next one and it gives a continuous pattern. Okay, that is why it is called as continuous spectrum. So what is the second point? It splits into 7 different colors. Each color merge into the next. It gives a continuous pattern, so it is called as continuous spectrum. Is it clear? Red color with longest wavelength. When we were discussing about the spectrum, we had seen that red color, it was having the longest wavelength, and the violet color, it was having the least wavelength in the visible region. Okay, so red color with the longest wavelength deviates least. देखो यहाँ पे जो white light है, here you will get red color, and on the lower side you will get the violet color. So यहाँ पे इसका deviation सबसे कम हो रहा है और यहाँ पे इसका deviation सबसे ज़्यादा हो रहा है. Okay, so we are saying red color का deviation सबसे कम हो रहा है और violet color जो है उसका deviation सबसे ज़्यादा होता है. And this is the diagram to explain the continuous emission spectrum. Okay, so 2 points you have to keep in mind whenever you are explaining the continuous emission spectrum. First point, white light from the source like sun, if it is allowed to pass and it is in a prism and then its splitting pattern, if it is observed, it is continuous. That means each color merges with the next and it is giving a continuous fashion. They are coming in a continuous fashion. It forms a continuous pattern. So they are called as continuous emission spectrum. I hope it is clear. Now, discontinuous line spectrum. Discontinuous or line spectrum. When gases or vapors of chemical substance are heated in electric arc or Bunsen flame. See students, in the definition of emission spectrum, we had written four types of sources. First one was sun, bulb. Okay. Second one was discharge tube में हमने क्या लिया था? गैस at low pressure and electric discharge हमने वहाँ पे पास किया था. ट्यूब के अंदर गैस है, लो प्रेशर पे मेंटेन है और वहाँ पे हमने इलेक्ट्रिक डिस्चार्ज पास किया है. That means to excite the sample. Okay. और second case में हमने क्या किया था? We had heated the sample so that the electrons get excited. So here we are taking that case where the sample it is either heated up with the electric arc or with the Bunsen burner. It first absorbs energy. अब क्या होगा स्टूडेंट्स, जब आप उसको हीट कर रहे हो तो क्या होगा, उसके जो एटम्स हैं they will absorb energy. Electrons energy absorb करके they will excite to high energy level, and when it goes to high energy level they become unstable and they jumps back, and when they jumps back they emits the radiations. Okay, so we are going to analyze these radiations. First absorbs energy and then give it out as radiations. They will give it out again in the form of radiations. जो radiation absorb करेंगे they will give out the same, which is then analyzed by passing through the prism. Just see the diagram over here students. Here I had taken the NaCl salt, and when it is heated up, the vapors of the NaCl they are heated up, then the radiations are emitted. Okay, now one of the ray of this radiation is allowed to fall on the prism. Now on the prism dispersion takes place, splitting will take place. Okay, now when we will see the pattern of the spectrum over here, it's a very surprising, very strange pattern you will get. It consists of distinct and well defined lines. Very important, distinct और well defined, बिल्कुल clear lines दिखाई देगी आपको. Okay, lines corresponding to definite पर्टिकुलर वेवलेंथ की वहां पे आपको लाइंस दिखाई देंगी, कलर्ड लाइंस दिखाई देंगी, सेपरेटेड बाय द डार्क स्पेसेस। बाकी सारा स्पेस डार्क होगा, केवल कुछ लाइंस वो भी कैरेक्टरिस्टिक है ऑफ द पर्टिकुलर एलिमेंट्स. सो यू विल गेट definite well defined colored lines in the emission spectrum, that is called as line spectrum. So इसी वजह से इसका नाम क्या है, line spectrum, because you are getting well defined lines and discontinuous है, इसलिए हम इसका नाम दे रहे हैं this is the discontinuous spectrum. Okay. अच्छा, अगर हम NaCl की बात करते हैं, if you are talking about this particular NaCl, तो NaCl का स्पेशल फीचर क्या है बच्चों, when it gets dispersed, when the dispersion takes place from the prism in the spectra, we are getting two yellow lines. We are getting two yellow lines here, which are corresponding to a particular wavelength, that is 5890 angstrom and 5896 angstrom. Okay. Now, no two elements have identical line spectrum. ये बहुत important point है students. किसी भी दो elements का line spectrum कभी भी same नहीं होगा, because they are having different energy level. They do not have identical energy levels. So line spectrum of the elements of the substances, it is used as a fingerprint to identify the particular substance. जैसे human beings के अंदर no two persons are having the same fingerprints, similarly here also in the case of substances, no two elements, they will be having the same line spectrum. So in the characteristics, suppose कोई unknown substance है, आपने उसका line spectrum observe किया and you are seeing two lines, two colored lines, that is the yellow lines. Here two yellow lines are obtained of this particular wavelength. तो वो identification हो गया कि yes, it is of NaCl. So line spectrum, it is also used to identify a substance. अब देखो बच्चों, ये जो line spectra है, ये बहुत important है, because Bohr when he was giving his atomic model, उसने सबसे पहले क्या डिस्कस किया था, line spectrum of hydrogen atom. जो नेक्स्ट क्लास होगी, in that we are going to take that line spectrum of hydrogen atom. But अभी in this class we are going to focus only on the atomic spectra. So here first I explain you the meaning of atomic spectra. Then we have discussed the first type of atomic spectra, that is the emission spectrum. It was of two types, continuous and line spectrum. Okay, so you should know basically what is the meaning. So now let's go through the absorption spectra. Let's see this. Absorption spectra. When a white light from any source, see what we are talking about, when a white light from any source is first passed through the solution or vapors of the chemical substance, means your white light है, first it is passing through the solution of the substance or through the vapors of the substance, then analyzed by the spectroscope. After passing through that solution, that is analyzed by the spectroscope. Spectroscope, that is the prism we are taking here. Some dark lines are observed in otherwise continuous spectrum. Students, क्या meaning है इसका? Some dark lines are observed in otherwise continuous spectrum. See, diagram देखते हैं, diagram से clear हो जाएगा. White light है, this is a white light coming, a ray is allowed to pass through NaCl solution. हमने वहाँ क्या लिखा है? First pass through the solution or the vapors of the chemical substance. So first it is allowed to pass through the NaCl solution. For example, we have taken the NaCl solution and then its dispersion is taking place. इसका डिस्पर्जन हो रहा है and we are supposed to get the continuous spectra. अभी हमने पहले यही देखा था, what we had seen in the continuous spectra, that the white light when it was passed through the prism, dispersion takes place and all the light colors were there in the spectrum starting from violet to red. Okay, and it was a continuous spectrum. Difference क्या है यहाँ पे? Here we had taken the NaCl. पहले हमने लाइट को पास किस में से किया है? NaCl, यानी जो भी सब्सटेंस है, first it is allowed to pass through it. अब सब्सटेंस क्या करेगा? It will absorb, वो चोरी कर लेगा. It will take some radiations of definite wavelength. Okay, अब ये जो यहाँ से white लाइट पास हो रही है, it will be having some of the radiations missing. Particular wavelength की radiations NaCl ने चोरी कर ली है, it has absorbed that. अब ये जो white light जा रही है इसमें कुछ radiations missing है, okay, and then when its dispersion takes place we will get a pattern. In this we will get some dark lines, and these dark lines corresponds to the color of the wavelength which has been absorbed by the substance. यानी यहाँ पे हमें continuous spectrum मिलना चाहिए था, but हुआ क्या है, कुछ wavelength की radiations absorb कर ली substance ने and they will be missing now. Okay, so here in NaCl we will get two dark lines. Yellow region में हमें दो dark lines मिलेगी, two dark lines in yellow region of continuous spectrum. अगर सब्सटेंस नहीं होता तो हमें एक कंटिन्यूअस स्पेक्ट्रम मिलता, बट हमने सब्सटेंस में से फर्स्ट व्हाइट लाइट को पास किया है, सो इट हैज एब्सॉर्ब सम ऑफ द रेडिएशंस, एंड व्हेन व्हाइट लाइट इज नॉट डिस्पर्शन टेक्स प्लेस, स्प्लिटिंग टेक्स प्लेस, तो जो हमें स्पेक्ट्रम मिला है इट इज हैविंग सम ऑफ द वेवलेंथ्स मिसिंग एंड दे आर एब्सॉर्ब बाय द सैंपल. ओके, और यहाँ पे जो मिसिंग होगी वो डार्क लाइंस कहाँ पे होंगी, इन द येलो रीजन्स, टू डार्क लाइंस इन द येलो रीजन ऑफ कंटिन्यूअस स्पेक्ट्रा. अदरवाइज वायलेट से लेकर रेड तक का वो पूरा कंटिन्यूअस स्पेक्ट्रा मिलेगा, केवल येलो रीजन में दो हमें डार्क कलर की लाइंस मिलेगी, अदरवाइज वो पूरा कलर हमारा जो कंटिन्यूअस स्पेक्ट्रा होता है वो हमें मिल जाएगा. सो व्हाट वी हैव सीन ओवर हियर, some dark lines are observed or obtained in otherwise continuous spectra. Okay, students, यहाँ पे जो dark lines मिलेगी, they are exactly the same. They are exactly the same colored lines which are obtained in the emission spectrum. अब देखो NaCl है, जब white light इसमें से पास हुई, इसने चोरी करी, ठीक है, दो वेवलेंथ्स की रेडिएशन चोरी करी, 5890 एंगस्ट्रॉम एंड 5896 एंगस्ट्रॉम की, ठीक है. नाउ व्हेन इट एमिट्स, जब एब्सॉर्ब करके हाई एनर्जी लेवल पे गए, then it becomes unstable, then they jumps back, and in doing so they emit the radiations, and जो इन्होंने absorb किया है they are going to emit the same. So in the emission spectrum we were getting two yellow colored lines. Okay, otherwise वहाँ पे क्या था, dark space थे, and here in the absorption we will get two dark lines. Okay, and in the yellow region of continuous spectrum. Is it clear? What is the difference between absorption and emission spectrum? Let's clarify it more with the help of a table. I had tried to summarize some points so that the meaning will be crystal clear, students, to you. Emission spectrum and the absorption spectrum. It is obtained when radiations from the source are directly analyzed in the spectroscope. When we had seen in the previous one that when white light was directly passing through the prism, its splitting was taking place, ठीक है, splitting हो रहा था, वहाँ पे continuous spectrum मिल गया था. line spectrum में क्या हुआ था, हमारा वेपर्स को हमने एक्साइट किया था, NaCl की वेपर्स they were excited, okay, and they were emitting the radiations and the radiations were analyzed. Okay, so हम यहाँ पे क्या कह रहे हैं, it is obtained when radiations from the source are directly analyzed in the spectroscope. Okay, अब हम देखते हैं absorption. It is obtained when white light is passed through the substance. White light को हमने substance में से pass किया है and the transmitted light is analyzed. अब ये जो light transmit हो रही है इसको हम analyze कर रहे हैं. So in the absorption the transmitted light is analyzed, and in emission spectra the radiation directly from the source they were analyzed. Okay, so the first point. Second one, it consists of bright colored lines separated by dark spaces. NaCl को recall करो, दो हमें bright lines मिल रहे थे 5890 5896 एंगस्ट्रॉम पे in the yellow region, and the remaining portion was a dark space. So it is saying it consists of bright colored lines separated by the dark space. Now see here, opposite है, बिल्कुल just opposite है. It consists of dark lines in the otherwise continuous spectra. बाकी सब as it is a continuous spectra है, but the dark lines will be observed in the otherwise continuous spectra. जिस लाइन को उन्होंने absorb किया है वहाँ पे क्या होगा, dark color हमें वहाँ पे मिल जाएगा. Okay, so these opposite effect of each other. Last point, it can be continuous. जो हमारा है emission spectra वो continuous भी हो सकता है if the source emits the white light, or it can be discontinuous or the line spectra if that means the line spectra of the source emits some colored radiations. जैसे हमने देखा था NaCl का कुछ colored radiations हमें मिल रहे थे. It can be continuous, it can be discontinuous, but here in absorption spectra it is always discontinuous spectra of the dark lines. Always हमें यहाँ पे dark lines मिलेंगी, कभी भी हमें यहाँ पे continuous pattern नहीं मिलेगा. Students, अगर continuous pattern मिल गया that means it is not absorbing anything. It is not absorbing anything. It seems as if the white light is directly passing, okay, and the splitting is taking place. But we had placed a substance and it will absorb some radiation. So always we will get the discontinuous spectrum of the dark lines. You can make your notes, students. I have tried to summarize. You will get in all the reference books in your textbook the book matter, but I have tried to summarize the atomic spectra, its division into emission and absorption, then the two types of emission spectra, that is the continuous and discontinuous, and the differences between emission and the absorption spectra. Okay, so students, I suggest you to make your notes and try to understand the topic, because you are not going to write the lengthy answers, but you should get the meaning, what do you mean by spectra. Why? Because in the next class we are going to discuss the emission spectrum of hydrogen, which give the board a clue how to give its atomic model. Okay, so keep on doing your studies.